Hello and welcome to another video. And today we have an Asrock B550 Phantom Gaming 4AC on our bench, written right there. Don't know what is wrong with this board. I got this in the bundle from eBay with multiple other boards. And I have really no idea what could be wrong with this. So we're going to see for the passive power consumption, going to build it up. And let's see how this board will behave. So, let's see together for the passive power consumption. We have 100 milliamps. Around 100 milliamps is very good. There are no LEDs on this board, so I wouldn't expect any higher. So, connecting power button and also finding the speaker port. So, we now have a 2200G in here. And also we have power button and speaker on here. Let me plug some RAM. So, some RAM is in. Let's get our DDR postcard. And also there's a TPM header on this, where I will try to connect the LPC card. And let's see if we can get anything on there. So let's try to hit the power button and see what happens. No reaction to the power button. Okay, first thing to check when we have no reaction to the power button, obviously, is to check if we have even voltage on the power button. So let's see, let's get a ground and see if we have the 3.3 volts, and we do have the 3.3 volts. So the 3.3 volts going low, we still have nothing. First thing I would want to check is to go around the SIO now and see for knocked off components, because the SIO is mainly responsible for startup. But before we do that, let's just try to reset the BIOS, because that can also lead to that. We have a BIOS battery with 2.955, which shouldn't be a problem, but let's get the BIOS battery out of here. So battery is out. Let's turn it off. There's a clear CMOS header at the bottom of the board. I'm just going to hit. So BIOS should have been reset. Let's try this again. And now let's hit the power button again. And still nothing. So pressing the power button, we get no reaction still. So let's go under the microscope. I suspect knocked off components somewhere, either on the backside or close to the SIO. So let's do that now. So now this is our SIO. Let's now see for the components around the SIO if we find anything that is chipped or knocked off or similar like that. If we see any damage in the area surrounding it. Often there are scratches then also close to where something has been damaged or knocked off, and that's also a good indicator. But it looks very fine here. There's nothing really here. So there are other ICs that often act like sub-SIOs, like this one here, but also looks fine. Let me quickly check if we have our 3 VSB and 3 VSBs present. I just use my test card for that. So another area I want to check is close to the CPU socket where we are right now. We are above the first PCIe slot. There's also VDD-P here, which should be 0.9 volts, and there's also our BIOS chip here. So far it looks good. Now we go closer to the actual socket. So this is directly under the socket. You have very often also knocked off components here. Let's see. That looks fine so far. Board looks really clean. Like, I haven't seen anything really being scratched or similar things like that. Now we are above the CPU socket. A lot of passive components, but also nothing. Now we go to the PWM controller at the top. But nothing so far. So now we are at the top left of the backside of the board. And this more looks like there has been something here. Like if you can see at these pads, they look like there was damage here on all of these. But I don't really think that any of these were actually actually had components on them. So I don't think there's anything knocked off, but we still can look into a board view and find out. So, but let's first have a continuous look on here. So, VRM section, backside. Let's see, I don't really think that there's going to be anything here that would prevent us from starting up or have a reaction to the power button, but still want to see. So the backside seems to have a little bit more damage, but this scratch right here, for example, is not deep enough, I'm pretty sure, to be anything. And now we are behind the PCH. A lot of passives here, but nothing indicating any signs of problems. Now behind the CPU socket, also a lot of components, but they all look fine. And there was some damage here close to this RAM slot. As you can see, these legs are bent. And if we continue here to the left, there's actually quite some scratches here. None of these for now look very deep. What is this? This is probably a USB 3.0 header. Yep, that's a USB 3.0 header. But there are quite some data lines, I think, here that we will need to check. So, what I first do in these cases is to first clean up a little bit to see if to get a better view of these traces. As you can see, it's way easier to see now where which trace goes and spot potential damage. So let's see now. This right on the right here is a very big track that pretty sure is not completely cracked through somewhere, because you would have to go along the whole length once. So this isn't a problem. These data lines right here, this might be a problem. This one right here is also a big trace. Don't think there's any problem here. Some of these traces might be a problem, like here. We will have to check like from somewhere here going all the way back to here. This big trace right here will also not be a problem because this is just one big pad. Then also this is not a problem, this is just the masking. But it might be a problem right here somewhere. And also this. So what I always do in these cases, I use my grinding pen. And I grind just a little bit off of all of these. And after some scraping, we open them up. So every trace now has at least one spot where they are opened. And what we do is we go on the other side after the damage and also check here. So we also do some grinding here and open up each trace at least at one spot. And now opened up again. Let's use some IPA. Let's see the very last trace. This is the big one. We don't need that one. And for this one also we have a upper one. And let's now get a lower reading for these. So go like here. And now we clean it up. So now we will need very sharp probes. For that I have specifically needle probes. If I can find my second one. So now equipped with my needle probes, we now go into continuity mode. And what we do is we go onto one of the sides of the traces and then go to another one, which would be here. Yep, we have that. And now we go onto each of these traces. So now let's check this one. This has continuity. So now going into the next one, going onto this one. This one has also continuity. And then going to this one right here. And this one has continuity. And for now, I don't really get a good signal on that one. Let me try to probe it better. It's kind of hard to probe right now. So let's see. I think it was the fourth one. So this one right here. And I wasn't able to get any contact on. I'm checking beside it. This might be an actual break. This trace might actually be broken somewhere. Because I cannot... But it seems like in general I get not a good contact. Let me grind it off a little bit more. Just to be sure that I have good contact when trying to probe these. So far I can't get any continuity. Let's check the others. Let's go from the left now. So let's try from the very left. So from here, we go right there. And I also can get a reading on this one. Ah, now I got. Yeah. So, able to get a reading on that. Let's check now this one, which is the second one from the left, which is a little bit bigger of a trace. This one we have. Now the third one right there, also a little bit bigger of a trace. Should be easier to probe. Yep. Let's now try this one again, which is hard to probe. So going on here. And I just cannot... Oh. There it is. Yep. So we have continuity on all of these. So it was really hard to probe. But all of this damage is not through the board. So we have two more left. We have these two left, which I also don't think are damaged, but let's try them. So we take this one. And on this one, I currently cannot get anything. So let's check the left one then. If I cannot get something on the right one. Let's see here. And the left one I can get. Let's try the right one. So far I cannot get a signal. Let me see if I can follow these traces where they go and find some better probe points. So we follow these two traces. Let's go down its path. Still these two. And there's one probe point. Oh, this goes all the way onto the spot. Okay, I won't be able to track that much. Let's see, where does it go at the top? Because these traces go all over the board as far as it seems. There's a probe point there. Let's see, where do these go? These seem to go like... What, into the VRM area? So, what is easy to probe? are these vias at the end. So these are easy to probe. So let's take these. So these are our upper ones now. We now have continuity mode. And this left one should go to one of the traces that I have drilled out. And this left one is definitely has continuity. But we were about the inner one that I couldn't get. So let's try to follow it. The inner one goes now here. All the way here. Let's see. Am I right? Yeah, this is the one. It's the upper one here. Going here, going this way. And now I need to be careful. It is the second one. Going down here. And now the second one from the top here. Now the third one from the top. Now the second one from the bottom. Oh, this is so complicated. So this one. The third from the top, which is this one, goes here. This is so hard to follow it still. It is this one going here, and going into that via. Whew, that is quite difficult. But I think we were able to follow it. And now checking, I know you can't see, but we do have continuity all the way. So we had to chase that all around the board, but we do have continuity between those 2 points. So none of that damage that we have seen here is actually too much. So all of this is fine. So what I want to do now is I want to check some voltages around the SIO, just to be sure that the SIO even gets power. But it should be getting power because we have 3.3 on the power button. But let's just see a little bit. Like this is probably 3.3. Oh, I don't have it plugged in. Oh, interesting. I don't get voltage here. Voltage here. Like I would expect that this is like pin 1. This is its main voltage. I cannot see the main supply for the SIOs anywhere here. Let's check that big capacitor if we have voltage across that. 0.6. Okay, this is not a supply voltage. We might need to see where the supply voltage actually is. Let's check this big capacitor right here. Also basically nothing. So usually I would check pin 1 for voltage. Like it's like this pin I would check, but I don't think we have any voltage here. Let's go into the board view and have a look at what's the voltage for the SIO, so we can check if that is actually running correctly or not. So now in the board view, let's see. Pin 1 was what I expected. SIO V3 volts. This is what I've expected, and I didn't get any voltage on here. Let's see, where does it come from? You have two capacitors just going to ground. We have one 2.7k ohm. This goes to the PCIe slot. We have one 1k ohm resistor. SIO power, okay. We have a 8.2k ohm. Onboard RST is on the other side of this, okay. We have another 8.2k ohms. This is M.2 reset, and we have a 0 ohm resistor connected to 3 volts. This only is present later, I think, because this is the normal 3 volts that we have here coming from the ATX power supply. And then checking this. This is also just a GPIO pin. Where does this voltage come from then? Let's see, what other voltages does this SIO carry? So there's a 1.8 volt on this SIO, but it doesn't really go anywhere. There's a 1.8 standby. This might not be even a standby. This is coming from the CPU. And I don't really think that this is its standby voltage from the SIO. So I can't really tell you what its standby voltage is, because normally it's the 3 volt VSB or even a own small regulator. So let me at least check the 1.8 volts then. So let's check for voltage. We're still in standby mode. So it should be this one. And we don't have the 1.8 volts. So that is not present also. So let's do it a little bit differently, because I really can't tell what on the SIO is important, like it's as voltage. Let's see for the power button. Where does this go? So we have a 0 ohm resistor right here. That then goes to another 0 ohm resistor for this MCU, and a 100 ohms resistor going into the SIO. And there's also a 3 VSB for the SIO PSN. Okay. So the 3 VSB is what gives us voltage here. So it might be that our SIO is not running actually. Let's see how these voltages are present here and also around this MCU here. So let's see now. We have no voltage here. We have 3.3 volts here. We have 3.3 volts there. We have 3.3 there. Question is, why don't we have... Oh, we do have it here. Okay. So now let's go to the MCU then, which is this chip right here. And what we need is this chip, 3.4 and 3.4. So that is also all present. And there's also this 0 ohm that is supposed to be right where the power button is. Not really sure. Let me see again where it's supposed to be. So let's see. This is the 0 ohm. And yeah, we have 3.3 there and 3.3 there. And what I need to do now is we go back to the SIO. Let's go there. And I will need to clamp the ground. So we want to actually press the power button while probing the voltage at the power button and seeing if it goes low or not. So let's see now. We now probe this point, seeing for the power button, and pressing the power button it goes low. So this reaches the SIO. Now the question is, does it actually go out? And I will also have to go into the datasheet of the SIO to see where its supply voltage should be coming from. So let's see that. So just once more, the actual power button is this one, not the one next to it. So let's see. This should be 3.3 volts. And pressing it, it goes down. And this is the PS out right here. 3.3 also goes low, PS out. Pressing it also goes low there. And this side only goes into the socket now. So let me try to clean the socket and plug in the CPU a few times in and out, and then also see where the PS on signal from the 24 pin goes. So after I've now checked the board view, let's see. This one should have 5 volts. And let's see, if we push the power button, it does not go low. Not at all. So our SIO is not working, because our SIO should be pulling this signal low now, because it goes, this signal right here, this upper one, comes from the SIO, and this side here is connected to the 5 VSB on the board, and this should be pulled low. So our SIO is definitely not working, and I will have to find out why our SIO is not working. Let's check once more for what is around it, and we will especially have to find out what is its power supply. Like, where is this SIO supposed to receive its power from? I will probably have to go into a data sheet to see that, because I couldn't really tell from the board view. So let me have a look where this NCT 6796D takes its voltage from. So going into the board view, not the board view, but the schematic of the SIO, I think I found where it needs to be. So this is supposed to be 3 VSB, I'm pretty sure. This is 3 VSB, and this side also has 3 VSB. So why why is the SIO not working? Because it does have its supply. So I think I might have found something. I was looking around because of the PS on and looking around the actual 24 pin, and I found this double NMOS, which is just corroded like I've never seen before, and the 2 resistors next to it. So let's go into the board view and see what this is responsible for. So this is our double NMOS, and it has this sleep state and VTT DDR on it. So I would expect that the sleep state could be the problem here. We also have on this resistor right here, VCCM and VTT DREF, we have corrosion, and also another VTT DREF. Okay, so all I want to do is to replace that double NMOS here, that NMOSFET, and see if that has helped then. So just desoldering it might also already help. So let me try that now. So, and as you can see now the new double NMOS is in place. It was quite hard to do because the pads were quite corroded. So a lot of flux, a lot of scraping, but it went down in place very nicely after that. And yeah, let's now try to power on the board and see if that getting rid of that corrosion already helped. So let's see now. We still have low power consumption, a little bit under 100 milliamps. And when pressing the power button, still nothing is happening. So that didn't change anything for us. So let's get deeper into the startup of a mainboard, and let's go for a data sheet of the SIO and also a power up sequence for mainboards. And yeah, let's see from there. So I want to show you something. I have currently 3.3 volts on my tweezers, and the power consumption is on. So the power delivery is on for the mainboard. And have a look what happens when I supply 3.3 volts here. Our board wants to start up, as you can see, by these lights, and we have 1.2 amps of power consumption currently, but the board is stuck. There's nothing happening. The CPU is getting hot, and our reset is also stuck on, as you can see by the red light on the PCIe tester right there. The bottom red light, that means that our PCIe reset is permanently applied. So there's still something wrong with this board, and I have tried to flash the BIOS on here. I don't know if I mentioned it, but I want to show you something. This is the adapter that I made. This is just taking, this is one of these adapters that takes a lot of different BIOS chips. And what I've done, I've just to one of its side connected this cable right here, this JTAG cable. This is a 2.54 millimeter pitch, I think, and this just connects to the header right there, and this can go with these pins, breakout pins, can just go into the programmer. And I've tried two different BIOSes, and it's sadly not the BIOS. So the signal that I was just injecting the 3.3 volts into was our SLPS3. So we are missing our sleep state 3 as far as I can tell. And I want to show you that on the, not schematics, but the power sequence of a motherboard and also the datasheet of the SIO. So this, what you can see right here, is the PS on block diagram for the NCT796D 6796D. That's what it is. And this is the block diagram for PS on. The PS on signal is the signal that pulls down the green pin on your 24 pin, which makes it give out 12 volts, 3 volts, and 5.5 volts, and also minus 12 volts and whatever there is also, but the main voltages. And this diagram shows you how PS on is being generated. So what you need is PS in and wake up. This is the VSB for the KB, where the KB is the SIO, and this generates PS out. And PS out we measured that. You also have VSB, that's the standby for the SIO. You have PS in, this is the same that we had here. And we have RSM RST. This is just another signal that is necessary for this flip-flop in order to work. And what you also have is sleep state 3, S3. And this is the only signal that I found was missing. You also have power enabled. Not really sure what this one is. Over voltage, PSN, RSMT, and this is also with S3. So also S3 is needed for this one to work in order to go into this one and then go to PS on. And the only signal I found that is missing is SLPS3. And I want to show you another image that I have for power sequencing. So this is an image for startup sequence. You have VCC RTC that you need from the mainboard to the PCH. This is just the RTC section. Then you have RTC RST. I've checked that also. We have 5 VSB. We have the SIO 3VA. This is the standby for the SIO. This is a 3VDSW. This is also connected via the 5 VSB. And this is for an Intel board, so it will be a little bit different than from what we have. We have the DP power OK that we already have. And then there's, starting with this power button, the SLPS sus, VSB enable, 5 volt dual, 3 VSB. We have all of these prior ones. We have the 3 VSB, we have the 1.8 of the PCH, we have the 1.05. I don't think the 1.8 is necessary for AM4. I think this is Intel specific. VSB detect, RSM, RST, and this is the important one. We have this, and then there's SLPS3 by the PCH to the SIO. And this info is very important. It says here by the PCH to the SIO, but this is important for Intel boards. Let's see what there is for AMD boards. And here we are with the PS on logic, again with the SIO, and you can see that PS on, you need to start this diagram from the bottom. You have 3 VSB, then you have the PS in. This is the 3 volt signal that, as you can see, goes high and then goes low by your power button press. And then there should be PS out going out of the SIO. So in between here, there's the SIO translating this PS in signal into a PS out signal. So it's pulling another signal low after you've pressed down the power button. And then, this is the important step. SLP S3 goes high by the Intel chipset, a little bit lower earlier already, as you can see. But for other chipsets, it only then goes high after PS out has been applied. And only with S3, as you can see right here, you get PS on. So we are missing SLP S3 currently because we have a different chipset. And let's go into the board view now. So we currently are in the signal steep state S3. Let's see, this is not connected. This is just a capacitor, not connected, not connected. A 0 ohm resistor. This 0 ohm resistor just goes into the SIO and nowhere else. This 0 ohm resistor is also okay. And the next one is not connected, not connected. This is the N-channel MOSFET that we had before. So this is here used on the gate, on the second pin. This sleep state signal is used for a gate. So it isn't coming from here. There's this 0 ohm resistor. This is for the enable signal for different voltages, as you can see right here. So this is also not where it's coming from, but this is an outgoing signal again on the second pin of a N-channel MOSFET as the enable signal. So going back to that 0 ohm resistor, we have a 10k ohm resistor where it's connected to. Going again into a MOSFET for enable signal, as you can see, pin 2 again. So going back to that 10k ohm, it's going into a 1k ohm resistor, and again, just for an enable signal right here. Right here, this is just a capacitor, and this resistor is not connected. So again, just driving a gate of a N-channel MOSFET. And then you have this logic gate driver where our signal is coming from. So let's go into the datasheet of this logic level. So currently, this is a single 2-input AND gate. So we have input A and input B. We're on 1 and 2. We have VCC on pin 5. Y is our output and ground is our ground. So let's see what we have on which of these pins. So pin 1 is one input. Pin 2 is an input. Pin 3 is ground. Pin 4 is our output. And pin 5 is our VSB. So our output is what we want. And we need to check our input signals. So SLP S3L is what we need to have a look at, where this is coming from. And the only connection from it is this pin right here on the processor. I've said this many times, but AMD uses a big part of the processor for doing things that an Intel chipset would do. And in this case, S3 is being also generated by the BGA, so by the processor, not by the BGA, but by the processor, I mean. And so one of the inputs is supposed to be high by the processor itself. The next input is also coming from the processor. So both inputs A and B only go to the processor, and both of them have to be high in order for us to get our output on this pin right here, on pin 4, to have sleep state S3. So let's check these two here and see how they're doing. So now this is our AND gate logic, and let's see now. We go into voltage mode, and let's see on this pin right here. We have nothing, and when pressing down the power button, we also get nothing. It should be this one here, but nothing. This is our 3 VSB, which is present. This is our output, which is not present as far as we know. And then this in the middle, this one is present. So this sleep signal is present, but our problem is this one. So let's check again which exactly this one is. We have the SO-A3 GPIO10, which is coming from the processor. This is present, but our pin 1 is not present. This is the actual SLP S3L. And this is connected to the BGA right here, and to the processor right here. And let's go under a microscope view and also check the resistance of this pin. So let's see for the resistance on that pin. So going into here, we have low resistance, which I would expect from the processor. So that was 26 ohms. And with having the processor removed now, let's see, this probably goes higher. Yeah, now we have high resistance. Now, following these, they obviously go into the processor right here. And we do know that the path is there because when putting in the processor and closing it, we now have low resistance again on this pin, as you can see. So the connection is definitely there. And it probably will be different if I put a different CPU in here. So let's just put, what is this, a 2200G now in here. Before we had the 3100 in here. And if we now check this signal, we now have 25. It's similar, but it's not the same. And when checking in resistance in voltage mode, trying to press the power button, nothing happens. We are not starting. So what I could do, let's try that. I want to know what happens if I inject voltage onto there. Let's now see if anything happens when I supply 3.3 volts onto here. And the board again starts up, but in the same manner as when we inject 3.3 volts by ourselves. So not a real startup from the board. Something is still missing for the board in order to wake up. And it's not only this signal, but this is one of the consequences that we have from something else missing. And the prop that you can see right now is my oscilloscope that you can see. And my oscilloscope does show 48 megahertz like this crystal is supposed to produce. So that is also not our problem, and our processor does get our clock signal. I'm still stuck at the same point. We do not have this signal, we do have this signal, and I don't know why the processor isn't giving out this signal. There's so much connected to the processor, so many signals that are needed that I sadly just don't know yet. All I can say is I've measured whatever I could from the power sequence, and it seems to be all there, and just this sleep state 3 signal is missing. I do not know what all the processor needs. The only things I know is that it needs VDDP, which is present, and we do have the standby voltage here. We also have the voltages 1.8 volts for the CPU, which is on this inductor right here, and also the 1.8 on this one, and the 1.8 that go onto the BIOS chip as well. We also have that, and yeah, don't know where to go from here. So, sadly, so far I'm defeated on this board. I do know what the problem is, that we do not have that sleep state signal, but I do not know why we don't have that. Why the processor isn't giving out the signal. I have checked multiple different CPUs, and it's all there. And the connection from that point to the CPU is also definitely there. We can see that. And there's still some signal missing for the CPU, and I just cannot figure out. I've looked all over the place for all of the if there's any broken components or knocked off components. I couldn't find any, sadly. And the sad thing is we don't have enough information about AM4. What signals are needed in order for the processor to give out sleep states 3. So yeah, sadly this is the point where I will need to end this video. But this is one of the main boards that I will not throw away or sell or anything. I definitely know what is missing now, and in the future I might gather the information or learn the information what is needed for the processor in order to give out sleep state 3, and then I might be able to fix this. I hope you could still learn something from this repair, seeing from all of the power sequence and the startup signals that are needed in order for the power supply to turn on and the board to react to the power button. So maybe some of you can help me in the comments, educate me on this, and help us to learn. But this is all I got for now. Thank you very much for watching. This was Mainboard Medic. All of my tools are linked in the video description. Thank you very much, and goodbye.